angle properties of a circle. Make sure you subscribe and like for more. I'm going to give you a summary in this topic, all the properties of circles in relation to angles. So we shall start with the first property. Even before we start with the property, we need to understand first what is a chord, what is a segment, then we have also a sector. So if you have a circle, you have the center, you know this one is the radius, then from this point to this point we have the diameter. So if you have a line, any line can be in any direction. Let's say you have this line AB, a straight line. So if you have a straight line AB joining any 2 points on the circumference of this circle, then we have a chord. You have a chord. Then this part, now you have an arc. This one you have an arc, just part of the circumference. An arc is just part of the circumference, so you have an arc. This one is the minor arc. Then if you go this side, we have the major arc. Then we have this one, this area which is enclosed, the area which is now enclosed by this chord and the arc. Then we have a segment. We have a segment. Sector mainly we usually use when you have an area which is enclosed by the radius, 2 radius and an arc. Then we have a sector. So if you know this definition of terms, then it will be easy now to look at these properties. So we start with property number 1. If you have a circle, then you have this chord AB or arc AB. I said arc will move along the circumference. Then chord is just a straight line joining any 2 points in the circumference. So if we subtend an angle from this chord or from this arc to the circumference like that, all those angles will be the same. For the first property, we have angles subtended by the same arc on the circumference. The circumference are equal. So you can have an angle subtended by the same arc or the same chord on the circumference, but they should be on the same segment. This major segment, we have the minor segment, then we have the major segment. All these angles are equal. So the second property, we have if you have a circle, then you have a chord passing through the center. So if you have a chord passing through the center, then this one becomes the diameter. If that chord subtends an angle at the circumference, that angle will be 90 degrees. So if it again subtends another angle, again it will be 90. Again 90. In this segment, half of the circle, this side. Again, if it is this other side, that will be 90 degrees. If it again subtends another angle towards that segment, also 90 degrees. So you have angle subtended by the diameter on the circumference is always 90 degrees. That angle is always 90 degrees. So this is property number 2. Yeah, property number 2. So you can look at property number 3. If you have a circle, then you have the center there. Then you have our chord AB or arc AB along the circumference. Then you have the radius. Then you have this angle subtended by the radius, not the radius, the angle subtended by these two. We have the arc, then you have the chord at the center. So this angle is subtended by this chord at the center, or the arc at the center. So if this chord again subtends another angle on the circumference, the angle theta, then you are saying that the angle at the center will be twice the angle at the circumference. So the angle subtended at the center by the same arc or chord is twice the angle subtended at the circumference. So you have that property. So we are saying that angle subtended at the center by the arc or chord is twice angle subtended at the circumference by the same chord or arc. So the angle at the center is twice the angle at the circumference, so long as it is subtended by the same chord or the same arc. So we have that property. Then another property, it involves something called cyclic quadrilateral. If you have your circle, then you have quadrilateral called cyclic. So a cyclic quadrilateral is just a quadrilateral whose vertices touch the circumference. Whose vertices touch the circumference. You can label these angles. So if you have this type of cyclic quadrilateral, you're saying that opposite angles add up to 180 degrees. For example, angle A plus B add up to 180 degrees. Angle C plus D adds up to 180 degrees. So you have the major 4 properties. The first property, angle subtended by the same chord on the circumference, they are the same. Another one, angle subtended by the diameter is 90 degrees on the circumference. Then we have angle at the center is twice the angle at the circumference, so long as it is subtended by the same arc or chord. Then the last one, we have angle subtended by a cyclic quadrilateral, opposite angles they add up to 90 degrees. Up to there, now you can tackle a question. It is usually 10 marks, so you give a reason and you show you're working. So a reason is always 1 mark, then you show also you're working.